So in the earlier video, we talked about how we can have a custom domain mapped to the Azure App Service. That is nothing but how we can have our own domain name mapped to the app service, which is running our own applications. Now, in this video, we'll talk about an app service feature called as an Autoscale feature. So we have an app service plan. So we have an app service plan. So we have an app service plan. I will call as an app service plan, which is talking about like a two cores with 8 GB RAM, 8 GB RAM, and somewhere around like let's say some 50 GB of storage space, which is part of that. Now, when we create an app service, the app service, so I'm saying an app service, which is I'm saying an acute or hrms.acutelearn.com. Now, this app service can consume up to the capacity of two cores, 8 GB RAM, and 50 GB storage space. Now, what happens if this capacity is not sufficient for this particular application? Now, initially, we have given a two cores, 8 GB RAM. So slowly, as the users got increased or usage got increased on the app service, we are seeing some kind of performance issues on the application. So how do we basically address this? So one option we have called as an scale up. So we have an option called as a scale up. So what is a scale up? For an existing particular app service plan, we can increase the capacity from 2 cores to 4 cores and from 8 GB RAM to 16 GB RAM. So this is one particular option where we are increasing the capacity, hardware capacities in the app service plan, which is going to help the app service to gain more resources and give the better performance. Now, this is one option, but when we do a scale up, there will be some kind of a disturbance or could be a disconnectivity to the application during this particular process, and but which could be a cost-effective solution. But if you see that, okay, by increasing the capacity from a 2 cores to 4 cores and from 8 GB RAM to 16 GB RAM, that would solve the problem, then we can go with an option called as a scale up. But we have another option called as an scale out. Scale out. So we have an app service. Now this app service is having a problem. That is the performance issues. Now Azure provides us an option called as a scale out. So what is the scale out is in? We can create multiple instances of the same app service. Now all these app service will have the same FQDN name and public IP address. Public IP address. So internally, the app service plans or an app services has a load balancer. So this is in the scale out feature allows us to add more instances of the same application as and when required. Now that way what happens is instead of running one instance of app service with the two cores and 8 GB RAM, we are running one more instance of the app service with additional two cores and 8 GB RAM. With two cores and 8 GB RAM. So one method is an manual scale out. Manual scale out. So which kind of situations we would use this manual scale out? Manual scale out can be used in situations where you see a drastic increase in the consumption of the application and drastic performance issue on the app service. And we see that the users are not able to access this application and having a performance issues. Now for temporary solution or for immediate, you want to address this particular performance issue. Now we can go for a manual scale out. So manual scale out is nothing but we are defining that add one more instance of this particular app service or two more instances of this app service or three more instances of this app service. So we specify at the time that whenever required, we go and basically scale out. That is what we called as a manual scale out. Let me go and create an app service. Let me select a premium. While this is getting created, let's see. So that is a manual scale out. So manual scale out is we define whenever we want it, we can go and increase the capacities without any kind of a conditions, without any kind of a criteria or a rules. And any point of time, we can reduce it. Let's say for temporarily, we got some increase of 200% user request. Now I can increase the count or instances to from 1 to the 3. Let's say after 3-4 hours of time, I feel that, okay, now the application got stabilized. Now I can reduce it. I can go back and reduce the capacity. Now we have called as an automatic. So we got called as an automatic scale out. So what is this automatic scale out is in? Azure will take a decision on behalf of us and add the instances automatically to your app services based on the utilization and based on the traffic which has been received on the app service. The Azure App Service scale out automatic can add the instances automatically. Now we are not there in front of the system. And automatically or unexpectedly, there is a huge traffic to the app service and drastic performance issue. Now automatic scale out is keep monitoring the performance of this particular app service. And whenever it sees that, okay, it is not able to handle the load which is receiving, then it will automatically add one more instance. Then now it has added two instances. Now the two instances, the load got distributed in two instances. After a specific period of time, again, it sees that these two instances are not able to handle the load. Then the automatic app service will scale out. It'll deploy one more instance. It'll deploy one more instance. So what happens now? Whether we are there in front of the system or not, based on the load and the traffic which is being received in the app service, the automatic scale out feature will keep on adding the instances based on the configuration, based on the configuration. So that way what happens is we don't need to bother about it. We can specify that automatic scale out that initially start with one. Start with one, the initial instances, and you can scale up to a limit of, we can define like in 10 instances, because there will be a cost which is being associated. Now I can define a limit of 10. So what happens in the case of this automatic scale out? So it starts with one, it will create a first at any given point of time, there will be one instance. And as the utilization increases, it'll add one more instance. And if these two instances are not able to handle the load, it'll add one more instance. If those three are not able to handle the load, it'll create a fourth one. Like it'll keep on creating as long as these app services are not able to handle the load up to 10. So we can define the limit to manage the cost. And we have called as a pre-warm-up. So what happens now? So if you want to create a new instance, it would take some amount of time, like in 2-3 minutes of time. It will take to deploy a new instance in the backend. To avoid that also, this automatic feature will provide a feature option called as a pre-warm-up. So what is this pre-warm-up is in? I defined one pre-warm-up. So always one instance will be up and running, and second instance will be in a shadow mode. So it deployed a new instance and kept it ready. Whenever there is a performance issue, it just simply route the traffic between these two. So now you'll be charged for both, because always a pre-warm-up will be in a shadow mode, which is created, will be up and running, but it will not receive the traffic. It will be in basically called as a suspend mode. So whenever it sees that, now this becomes active, immediately it basically creates a one more instance for pre-warm-up, which is in a shadow mode. So that whenever a huge amount of load is coming in, there is one instance which is always ready to handle the traffic immediately without having major issues with the users or accessing applications. Now, this is one feature called as an automatic scale out. So when we go to the app service, under app service plans, we see called as a scale up. The scale up, as I said, we can increase the capacity of the app service plan from 2 cores to whatever required capacity. Now, as of now, the app service is running with a 2 process with 8 GB RAM. Now, if I feel that this capacity is not sufficient, then I can basically do called as an increase to the 4 process with 16 GB RAM, or I can reduce it. So when you feel that, okay, now if I increase this to the 4 CPUs and 16 GB RAM, and you are ready to pay always for the 4 CPUs and 16 GB RAM, then you can go with a scale up. But what is the advantage of a scale out? So if you really lose see from a scale out option, so I'm running with the 2 cores and 8 GB RAM. I'm paying for only this capacity. But whenever there is a performance, I'll deploy a new instance and I pay for additional 2 cores and 8 GB RAM. So I'm not going to pay for 4 cores and 16 GB RAM all the time. But if you do a scale up, you have to pay for 4 cores and 16 GB RAM all the time, whether it is in use or not in use. But what advantage we get is from a scale out? Yes, it is running with the 2 cores and 8 GB RAM. Unfortunately, now we see a lot of traffic. Maybe for the next 2 hours, we might see the traffic. Now I can do a manual scale out with additional 2 cores and 8 GB RAM, and I'll be charged only for additional 2 cores for the next 2 hours until I reduce it. If you go with automatic scale out, what happens here now? Yes, you initially started with the 2 cores and 8 GB RAM. The cost is very less. And you are having a pre-warm up when, which is 2 cores and 8 GB RAM, you are paying for this one. But whenever there is a performance issue, it'll add one more instance. And when the performance issue is resolved, or basically the traffic has been come down, then automatically it reduce the number of count instances. So let's say in a day, given a day, every day at 9 a.m. to 11 a.m., you see a lot of users traffic like HRMS applications because we do and time in leaves, all these kind of things. There could be some kind of an activity on the HRMS application initially. So now during this particular period of time, I want a better performance. So the Autoscale feature can run more instances only for that 2 hours of time based on the utilization and gives the best experience for the user. So now we only charge for those 2 hours of time, which is running additional instances. That is the advantage of scale out. So when you go for a scale up, you always pay for the capacity which you upgrade. But when you go for an auto scale, you only pay for whenever it is being added. So either it can be manual or automatic. Now I go here. So I upgrade the capacity to this one. Now this is scale out. Now the scale out method manual. Now as of now, instance count is only one. So it is running only one instance of the app service. Now I can increase these two services or 5 or 2, whatever I need it based on the requirement, based on the traffic. Now when I do a save, this is a manual. Now Azure will charge you for 2 instances with the same capacity. Now you see that active instance count is 2. So when you go to the app service, you will not see these 2 instances. They are internal. We always see only one. But in the background, it'll run 2 instances of the same application. The URL will be the same. The background public IP address will be the same. Only thing is that in the background, Azure App Service is trying to add one more instance and distributes the traffic across both the instances. Now, whenever we don't need this capacity, we can reduce it. We can reduce it. Now, advantage of this one is that there is no downtime for your application. There is no downtime for your application. So this is what we call the scale out method automatic manual. Now we see automatic. So what happens in a case of an automatic? The Azure will monitor the utilization of the app, service. Maximum burst, how many instances it can go. So I'm saying called as 4 instances so that I don't want to go beyond 4 because there will be a lot of cost associated. Always ready instances. I want to keep 1. That is what I called as a pre-warm up. Okay. So what happens now? It starts with 1. It can grow up to 4. In the shadow, it'll keep 1. It'll keep 1. Now, whenever a user traffic gets increased on the app service, then this automatic scale out feature will automatically increase the number of instances based on this one. Okay. So active instance count you would see here in the metrics, or you'll be able to see based on the load, it will be, as of now, it will be 1. So based on the consumption, everything, it can increase it. That is what we can see from the automatic scale out. Now, third option we have called as an rules based. So what is this rules based? One kind of a requirement is in, so I have this app service. I have this app service. Now, every Saturday and Sunday, and scheduled jobs will run. So my requirement is in every Saturday and Sunday, a scheduled jobs will run, which consumes a lot of resources, and I need the best performance of this application because there will be a load. Now I can define a rule, that a condition, I would say called as a scale out condition. So what is that? A condition I can define is an on a specific days and specific duration or a specific time. So I can define that, okay, every Saturday, Sunday and Sunday from 6 a.m. to 1 p.m. add 5 instances. Add 5 instances. Now what this method will do is whether there is a load or not, whether the consumption is high or not, on Saturday at 6 a.m. there will be 5 instances of this particular app service will be running till 1 p.m. After 1 p.m., again it will bring back these 5 instances to one instance and keep it as it is, or based on the minimum required quantity what we specified. This is one kind of a condition. A second kind of a condition, which I would say rule based. I want to have whenever CPU utilization reaches 80% greater than, or I would say greater than 80% consecutively for the period of 5 minutes, then I want to add one instance. So now in this case, what happens is so when a CPU utilization of one instance reaches 80%, it will deploy one more instance. When the CPU utilization of these two instances reaches more than 80%, then it will deploy one more instance. It will deploy more than another one more instance. If the utilization of these three instances is more than 80%, then it will deploy one more instance. Based on the limits we configure, if I space that the maximum number of instances are 4, it can scale up to 4 starting from 1. Once it sees that, okay, the utilization has come down, then it will automatically remove one instance. When the utilization has come down, then it will remove another instance. When the utilization has come down, then it will reduce one more instance and keep one instance out of the minimum quantity which is there. Now, so you can have a rules based on the utilization conditions or based on the days which is required. Now, this scale out option enables us whenever we want to have a better experience or better resources required for the application, we can add up instances. When it is not required, we can scale down so that we can save a lot of costs. Now, typically we see this kind of a behavior. In the first week of every month, there will be a lot of load on the banking applications because all the users will get salaries. Then they will be doing a lot of transactions like transferring EMIs, okay, then withdrawals, then payouts, salary, I would say called as and rentals like purchases, so many. So what happens now during the first week of every month, the banking applications, we see a lot of traffic. Now in this case, kind of case, what happens now? If you can say that, okay, based on the performance issue, it can automatically scale out. So that is the beautiness of this particular feature. Now let's go to the rules based. So configure the rules. So I'm saying a custom Autoscale. Name of the Autoscale name. Default instance will be 1. Delete warning. When do you want to delete it? So basically the very last default resource cannot be deleted. This is the default one. Scale to a specific instance count. How many counts you want to, whenever a condition is being executed, how many instances you want to, either based on a metric or based on the instance count. Okay. I'm saying one instance, you add it. Okay. So what is that? I'm adding a scale condition. I'm saying that, okay, add one instance whenever the condition is in. I'm saying specify start and end dates. So I can specify the duration for which I want it, or I can specify the days. I can say that every Saturday, Sunday from 6 a.m. to 11 a.m. I want one instance to be added. One instance to be added. So if I space 2 instances or 3 instances, then every Saturday and Sunday, automatically it will add 3 instances. So whether there is in consumption or not consumption, automatically on Saturday morning, 6 o'clock, it will spin up additional 3 more instances. At 11 a.m., it will turns off these 3 instances. Sunday morning, it adds 3 instances and deletes 3 instances at 11. So this is the one kind of an condition. I'm going based on a metric. Minimum is 1. Maximum, I'm saying that 4 instances. Default, how many you want it at any given point of time. I'm saying called as a 2 instances. Repeat specific days. Do you want to have an every day? So I can specify that, okay, Monday, Tuesday, Wednesday, Thursday, Friday, 6 a.m. to 11 days, have 4 instances and this thing. Specify a start dates based on this one. You can do that. Add a rule. Now I'm saying called as an metrics, CPU percentage. Now what is my condition? If an operator threshold is equal to 70% for an average duration of 10 minutes, okay, then basically trigger an action, increase the count by 1. So it is going to add 1. So I'm specifying a metric of CPU, standard CPU percentage. Okay. So I'm saying that if you want to have different metrics, you can take data in, data out. It depends on the requirement. Let's say you have some kind of a video applications like YouTube or TV news or basically like a Netflix or these kind of things. There it requires a lot of bandwidth. Okay. But some based on the metrics which you want it, you can take what you want to measure it. Then the number of the CPU utilization is greater than 70% for a consecutive period of 10 minutes. Then I'm saying that increase the count by 1. Okay. So now it adds 1. Cooldown minutes means it checks 5 minutes. If it is utilization is less, then it'll bring down. So like this, you can define the rule-based conditions. Now the auto scale, either on the days or in these things, it can automatically increase the capacity instances based on the rules which you define it. Okay. That is the beautiness of this particular feature. Whenever we want to have it, we can do this one. Okay. So you can save a lot of cost by using the auto scale out feature. At the same time, we can achieve the performance and give a better experience to the users. This is how, but the good advantage of this is that you don't need an external load balancer or anything, because inbuilt all these app services will have one same an FQDN name and public IP address. So that's how you can configure the auto scale feature and you can use it.